And hey there, students and teachers, and welcome to early November of 2020. The chronology here is not uber important. I do put us against the backdrop, if I can get my browser to open. I do put us against the backdrop of what was going on in the elections, right? So, and also against the backdrop of what's happening with the virus. The death rate per people entering the hospital is going down, but if you can't go to the hospital because they're overwhelmed, see, that's an issue. If you need that kind of help. And what's happening in this part of the year is people are going indoors more because it's colder. And actually, the US is having as many new cases in one day as all of China had in the duration up till now. So that's pretty exciting. I say that sarcastically, or uh, it's not a good situation. Private party, I still care about. The election's over, more or less, and I've been putting my postmortem on Facebook, right? And these are public posts. Anyone can read them if they care to see what I'm going on about. It's, I think, a prime time to take advantage of people wondering if the election was rigged. I'm saying in what sense it was well narrated and people are as secure about this transition of power as just about any of recent vintage. But in terms of really addressing underlying issues of the corruptibility of election software and so on, I'm just pushing greater numeracy, computer literacy going forward and in the high schools. As I put it, my party line is if Americans were sincere about wanting high quality voting technology, they'd learn to vote often in high school for Miss Geometry or whatever, using open architecture machines with open source crypto, the same ones used in public. There could be there's a smartphone API as time goes on. Further on, I say, well, we won't have to get into this now, I guess. I just encourage us to get enthusiastic about voting again. That's something I talk about there. And I won't talk about the blockchain or anything because what I really want to talk about, I'm signed up to teach adults now through Coding with Kids. Whether I do or not is a separate question. But partly to stay warmed up for that and give you something to chew on for free, no commercials, I'm not monetized, shouldn't be interrupted. Just a little bit on this Pascal's triangle thing in Python. And on the left, you see a lot of text in green, and that's because it's all what we call comments. Notice the triple quotes up here. It's actually more correctly known as a doc string, DOCSTRING, DOC for documentation. And at the very top, it's considered a good idea to just tell us all about what you're doing here in your module. This whole thing is called a module from top to bottom. And at the bottom, this is something you'll find whole YouTubes on. It's saying if you're running me as top level, in other words, if someone hit the green button or invoked me at the command line, if I'm running, I being the module, sort of in captain mode, I'm the captain of the ship and it's up to me to do any importing that's going to happen. Well, in that case, I want to test this module. In other words, my job, if you run me, is to run what are called documentation tests or doc tests. And that's a very interesting feature in Python, that you can write a short snippet of dialogue, such as I do here, using the prompt, interactive prompt mode. It's really just a static string, remember. This is not actually runnable code, but it's a dialogue. Somebody goes demo, and whoa, it's supposed to print out all this in response. And if it doesn't, you see, that will be caught by the doc test. So it's really an auditing machine. It's saying, hey, does this stuff work as advertised? And as it is, I have not put in any tests of Demo 2, which I just added recently for a recent video. What we were talking about earlier was a convergence to pi, and was it verifiable? And I don't want to go down that exact rabbit hole this time. This was one of the numbers we were dealing with. It's actually a giant fraction, numerator, denominator. That's just the denominator of the fraction. One feature of my curriculum, which is rather unusual, and I don't know if you'll have encountered it very often before, is I believe in using super high precision decimals and also integers with huge numbers of digits, so-called big integers. Partly because I'm stressing the true power of computers to do that. That's a selling feature of Mathematica, for example, is that you can dial in the level of precision you want to pretty much any algorithm. And that includes going out to thousands of decimal places if you have the memory for it. And Python can do that too. It's just because of exigencies in the curriculum, because of happenstance, the way I look at it, we don't go there usually, especially in the introductory levels. And I think, why not? This is where we're really proving the power of computers over calculators. And a lot of people are still trying to make that transition from the calculator to the computer. And what Python offers in that regard is interactive mode. Just like a calculator, you type, hit enter, it comes back with an answer. That's called a REPL, read, evaluate, print, a loop. And only some languages have it. It makes it interactive. DBase had it, where I cut my teeth as an applications developer. APL had it, the first language I learned, along with Fortran, which didn't have it. It had only punch cards when I started. But even today, like C or Java, you're not interactive. You're writing your code, you're compiling it, and then you're running it. Whereas if you have a REPL, you can do 2 plus 2. It's very much like APL in that Python has many small little orthogonal functions, meaning they work together without stepping on each other's toes. Let me just show you one of them. If I have 0, one of the little utilities, if I have 0, 1, 2, 1, and I zip that up with 1, 2, 1, 0, what am I going to get out of this? Let's just say results, whatever you give me, let's take a look at. Okay, something's named results. I can ask for its type, and it's a zip type thing. What does it have as far as methods, I wonder? Can I use next on this thing? Let's just try. The fact that it gives me a nice prompt gives me some hope, but let's just try. Next, yeah. What did I get out? 0, 1, let's do next again. 1, 2, let's do next again. 2, 1, let's do next again. 1, 0, does this go forever or what? Some kind of error message. Stop iteration. Something got triggered there. So I'll explain it. Basically, a lot of you already know this. Zip takes the leftmost element in the first and pairs it with the leftmost element in the second element. In other words, the elements that go into zip already have sub-elements. And we pair them up, although we can have 3, 4, 5, 6 multiple arguments to zip, and they all get the same treatment. We take the leftmost element of all of them and make a tuple out of that, and then the next most element, and the next most, and so on. When any of the elements runs out of sub-elements, then we're done. For example, if I go zip, and let's use characters this time. In fact, let's do really quickly, let's do some breakfast foods, and we'll use a list to show you don't have to use a tuple here for input. Breakfast could be like eggs, oatmeal, what else do people have for breakfast? Waffles. And For lunch, we'll just say I'm going to go with kind of a Western diet here. I would encourage you to use emojis if you would like instead, and you don't have to stick to anything typical. Tuna fish sandwich, that's really verbose. That's a long food. Let's see if we can keep it shorter than that. What else might people have for lunch? Around here, a burger, just make it simple. And let's stop right there. It only has two sub-items. In dinner, we're going to go to one or two. Let's see, we'll do steak and potatoes, kind of unhealthy, not something I would usually go for, but hey, I've had my share of all of these. Steak and potatoes and dessert, very unspecified. What the? That's not very useful. But there's only two of those too, and right, there's three breakfast foods. So how can we zip these? Is it going to cause issues? Zip. This might be my daily meal, breakfast, or my daily intake, my daily consumption. So I'll say what I ate will be my name for this output. And then if I go next, what I ate, you know what's coming, right? It's going to take eggs, tuna fish, steak, and potatoes, and say like that was my Monday. Eggs, tuna fish, steak, and potatoes. And then next again, what I ate, oatmeal, burger, and dessert. And then next, what I ate, but wait a minute, breakfast has waffles, but lunch and dinner have nothing for the third element. So there's my stop iteration. As soon as one of them hits a dead end or hits the end of the road, the whole thing has to stop. Even if 20 of them have 30 items and only one of them has 28 items, we'll stop after that 28th. It doesn't keep going for the benefit of for the rest. Now, if you wanted to pad it out with nuns or do something on your own to fix that, or even subclass the zip type, I suppose you could do that. So basically, Pascal works that way by sticking a 0 in front and a 0 on the end of a list, and then just using zip first and then adding those pairs. So this little piece of the doc string kind of sums it up. I did 1221 a second ago, but 1331 would be the next level down. In fact, now I can't keep using the results of a zip. Once I've used it, it's exhausted. I have to go back and get it again. So if I want that result again, I could run it again. And let's just do a for loop here. For K, let's see, for item 1, item 2 in result, print item 1, item 2. I'm just making up those names I1, I2. It probably should be I0, I1. Just given the way we think in Python, we start numbering from 0, but this is totally irrelevant. I mean, I could call it X and Y, I could call it anything I want. What I'm showing you here is that when I start over with my new zip object, my new result, and put it in a for loop, it's going to do that looping thing, and it's going to give out those tuples, but it's not going to have a stop iteration error. And that's because the for loop is waiting for that, and when the stop iteration occurs, it gracefully exits the loop. Really, a stop iteration is what it says it is. It's a signal to whoever's doing the iterating that it's time to stop. And so the for loop doesn't take that as a big error, it takes that as an expected flag or symbol, or signal I should say, and yeah, it stops gracefully, no issues, no problems. So 0, 1, 1, 2, all right, so let's get that result one more time. And this time, I'm not going to just print it out, I'm going to add these two up. So print 0, item 0 plus item 1, add them, okay? And what do we get? 1, 3, 3, 1. Well, that's the next row of Pascal's triangle. And now if I put a 0 in front of that, and a 0 behind that, and I zip them up into pairs, 0, 1, 1, 3, 3, 3, 3, 1, and 1, 0, and I do this addition like I just did in this expression right here, then I get the next row, right? So let's just look a little bit further down. Let's see. Yeah, so these would be the rows coming out. And let's just look further down at the source code itself. This is all that's going on with Pascal. Those few lines of code. And I actually stretched out this list comprehension into 3 lines for readability. But what it's really saying is add a 0 on the end of the current row, prefix a 0 to the beginning of the current row, so you're going to have the same numbers, same number of numbers, because row's the same, 1, 2, 2, 1, or 1, 3, 3, 1, let's see, it's 1, 2, 1, not 1, 2, 2, 1. This is my first, yeah, just 1, 2, 1, not 1, 2, 2, 1. But now it's 1, 3, 3, 1, because we get one more number every time. It gets longer and longer, this Pascal's triangle. And every time what we do is we put a 0 on the end, a 0 on the back, add them up, add up the resulting pairs, and that's our next row. Very simple. But what's cool about yield is, unlike a function which ends with return, return is the trigger to hand back control to whoever called you, and hand back control with a result. Now yield works the same way. Hand back control, we're done here for now, give back the row, whatever the result is, but then you're basically paused. And when you're triggered again with a next, you're going to pick up right where you left off, and you're not going to have forgotten. In the meantime, you're not going to have let go of any of your local variables, such as row here. It is going to stay paused, remembering the most recent row you've done. And every time you go next, because of the while true loop, it's going to circle around, loop around, and come right back to the same yield over and over. But each time you do that, it's going to have the next row ready for you. So what's this whole thing called? This module in general is called Pascal. So import Pascal. Pascal.Pascal. This is a common thing you'll see, is that the module has a name, but then inside of the module is some function or callable object, generator in this case, generator function we call it, and it starts with no arguments, and it returns what's called a generator object. So the first step in executing a generator is not that you get the first result, like the first row. Rather, you get back an object that's ready to be nexted. It's ready to be fed to next. Like it hasn't even executed any rows yet. By creating this generator object, I haven't run any of the lines of code yet. But when I say next, it will run up to this first yield, and in the meantime, it will have acquired a value for row of just 1. Do it again, and it goes through that rigmarole I just showed you. And there we are, 1, 1. And I'm going to keep going, and there we go. The rows of Pascal's triangle. And because of big integers in Python, it's not going to take long for this to have some pretty big numbers. Python will be able to handle it. Let's go on with the for loop. For whatever, we often use underline, meaning we don't care about the name. For whatever in range 50. In other words, for 50 more times, let's just go next p. And it's going to print them out, but I'm not going to want to print them out. I'm just going to say p equals, no, not p equals. I got to keep q equals. This is just to suppress any kind of printing out to the REPLs, so we just have a nice clean interface. It just went 50 more iterations, and now if I look at q, look how some of those integers are getting to be pretty big. Now let's go another 50, Okay, pick up where we left off here. This is not starting over. Another 50, and now look at the size of some of these integers, and we can keep going here. We're getting beyond what a calculator could do, right? So that's Pascal's triangle in a nutshell as implemented in Python, and what we do in an earlier video now, you'd need to go back in time in my chronology. What we do is take this conjecture that we can approach pi using numbers taken from Pascal's triangle according to a certain pattern and converge to pi, right? We explored that possibility. I'll say no more at this point. So that's kind of where we'd start in a Python course because, you know, I'm assuming in high school or in middle school, the idea of a callable function is already somewhat in your consciousness. In other words, a lot of what I'm showing you has to already seem somewhat intuitive. The fact that you can pass what we call arguments to what we call callable objects. That's a kind of a notation that any textbook in my era, like I started going to elementary school in the 60s and finished high school in the 70s, I would say anyone in school in the 60s and 70s would not be thrown off by the idea of passing an argument object to a callable object. So we kind of dive in right away with that. We don't have to say it's like it has a mouth and it's eating and all that. But you can do that with kids, right? If they've never had math before and they're learning math for the first time, write like this. This is like as soon as you know how to type at all, you're starting to write code and learn math this way. Well, then we might introduce the notion of callability a little more formally. You know, you can ask if something's callable in Python. I'll just show you that. Callable, this thing that I've been feeding to the generator called P, that's not callable, right? I can't call the generator itself. I don't go like P like that, right? P is a generator, but I don't call it. T type of P is a generator, but it itself is not callable. I feed it to next to get the next row of Pascal's triangle, but next is callable. Next eats, next has a mouth. Even if it doesn't take any arguments in some cases, in this case it does. It expects at least one argument, in fact only one argument. So anyway, all these kind of concepts are sort of in the background of numeracy in general, and where we start depends somewhat on the contextualizing curriculum and how tightly have we wound this in together with everyday mathematics. And you know, my approach, which is not to distinguish mathematics and computer science so strongly. They need to be integrated into kind of a single subject. We talk more about that in my rebooting case through 16 video, which I invite you to watch next. And hang in there, guys. Talk to you soon.